All right, so what did you guys think about, is there a linear relationship? Is there? No. Why not?
There's no consistent slope.
Right. If we see that these are equal length intervals, so they're all changing by 3, then we don't necessarily have to find the average rate of change. We can just find the first differences for this, and that's what I did. So we're going to say the first differences of output values are not constant. Now, if you actually found the average rate of change by dividing each one of those by 3, then that's fine. You could say there's not a constant average rate of change. All right, what about quadratic relationship? No. And it's the same reason, except it's the second differences of output values are not constant. Did anybody find the third differences? You didn't have to. The third differences are actually a constant. So I'm gonna, if you guys have some space, I don't know how many you found, but I have space because I didn't find any. But the third differences are constant, and they are 21.6. Okay, so you're interested. What do you think that means about the type of function it is? I don't think you've learned this before. What? It is a cubic, yeah. S is a cubic function, which is the type of polynomial function that the largest exponent is 3. Okay, and then we still have this S function about the stocks, but we have a graph this time. And so we're going to estimate the first time the value starts to decrease. What would you guys say? Between what 2 days does it look like? I thought it looked like between 2 and 3, but it's not a big deal. It's at this point right there. Do you guys remember, like, as far as characteristics of a polynomial graph, what that's called? That peak of a mountain? Okay, remember? That's okay. It's a relative maximum. All right, and then does the value of stock ever reach 0? Not really. If you zoom in real close, it's hard to zoom in on your paper, but no. And I just said that to explain is there is no x-intercept. What is that point called?
Relative minimum.
Good. Right, and then C asks, on which day in February, in these 28 days, is the stock the highest? What do y'all think? Day 28. And on that day, I said it was about $450. And that's something you may or may not have learned before, but that's going to be an absolute maximum. So you see absolute highest point. Those can occur at relative maximum points, or they can occur at endpoints. Does this one have an absolute minimum? It should. Yeah, this is also the absolute minimum. All right. Number 3, it's a big question. We're going to try and get this straight in everybody's head. So is the rate of change of S increasing or decreasing on the interval from 3 to 9? Not is S increasing or decreasing. Is the rate of change of S increasing or decreasing? What do you think? Decreasing. Why? Concave down. Very good. All right, and then for the first 20 days of February, use the graph to estimate the day in which the value of stock changes the fastest. So what do you guys think? First 20 days. What would you guess? I guess 10. That is an actual special point. Do you remember what it's called? This is where the graph is changing from concave down to concave up. Point of inflection. Very good. All right, so I'm gonna go ahead and give you the note sheet and then we'll finish this table in the back in just a second. There's a few things I want to talk about first. All right, so we are talking about polynomial functions, and we actually have been talking about polynomial functions also, but linear function is considered a polynomial function. Quadratic function is considered a polynomial function, but any function in this form where this n is a whole number is considered to be a polynomial function. So this is some whole number. This next one is one less than that whole number, and it goes down to where you just have a constant. And whatever that largest power is called the degree of the polynomial. But if you ever have a function with the exponent is a fraction, or the exponent is negative, or the exponent is a decimal, those are not polynomial. Polynomial exponents have to be whole numbers. All right, and then we aren't going to talk about a sub n today, but the number in front of the variable with the largest exponent is called the leading coefficient. We will definitely come back to that because it tells you a lot of things about what the polynomial is doing. All right, and one thing to keep in mind about the graphs of a polynomial function is that they have smooth, rounded turns. You aren't ever going to have any sharp turns like you would like an absolute value function. That's definitely not polynomial. They're all going to be kind of smooth turns. Okay, and then another word to describe relative maximum values, relative minimum values is relative extrema. That just like includes all of them. And it's going to be the location of the peaks and the valleys. And something you might have heard in Algebra 2 that you'll definitely hear from me quite a bit is that a relative maximum occurs when a function changes from increasing to decreasing. So that's going to create a relative maximum. So the function changes from increasing to decreasing. Now, the relative maximum also can occur at an end point. Now, most, polynomial functions don't have endpoints, but it could be a situation like the one with the stock market where you're only looking from day 0 to day 28. So you're only looking at part of the function. All right, and then the relative minimum is going to occur when the function changes from decreasing to increasing. Or if it's a contextual situation where you're only looking at part of the graph, it could also occur at an endpoint. All right. And then the absolute extrema, they're going to be the highest and lowest y values of the function. Now, it's possible the function doesn't have absolute extrema. Like it's going to keep going up in one direction and keep going down in another direction. There's not a highest and lowest point. Or it could just have one and not the other. So keep that in mind. The same thing with relative maximum and minimum. They don't have to exist in a function. All right, and then we kind of figured this out with the cubic, but a polynomial of degree n has constant n differences in output values over equal length input value intervals. Now, I've already kind of started thinking about the next test that we're going to take, and there's going to be another question like that one you had, that free response, where you decided if it was linear, quadratic, or neither. But on the next one, it'll be linear, quadratic, cubic, quartic, neither. So you're still going to do the same thing. You're still going to practice wording everything correctly. So the more you practice, the better you're going to get for sure. All right, let's look at the back of the stock market. You might want to, at the top of that stock market page, say that there's important information on the back, because I feel like this is going to help you. I hope. All right, so these are if-then statements. So if f of x is increasing on the interval from a to b, then that means that the rate of change, or in the place of rate of change, you could say slope. The rate of change or the slope of f is, would you guys say the rate of change or slope of f would be positive or negative if f is increasing? Positive. On that same interval. So the interval from A to B. Right? If f is decreasing on an interval from C to D, we're going to say the rate of change of f is negative, or the slope is negative on the interval from C to D. So that was stuff we've already talked about. We might not have worded it that way. We might have said slope instead of rate of change. But the next two are from today. So if f changes from increasing to decreasing, you can draw it if you need to, changes from increasing to decreasing, what is going to be at that point? Relative maximum, thank you. So we're going to say f of x has a relative maximum at x equals b. Right? And then this one is kind of the same thing, but f of x is changing from decreasing to increasing. So that's going to be a relative minimum. All right. And then The next two are about concave up and concave down. So if we know f of x is concave down on an interval, what is that telling us about the function f? What's increasing or decreasing? F isn't necessarily decreasing. What is decreasing? The rate of change. Good. So the rate of change of f is decreasing because down is decreasing on the interval. This is g to h. Okay. And then the next one is the same thing, except concave up means the rate of change is increasing. Right, and then the last one, f changes from concave up to concave down or concave down to concave up at x equals L. So the concavity changes. What is that on the function? So point of inflection. So f of x has a point of inflection at x equals L. So until all of these like different rates of change and stuff is like straight in your head, I would kind of keep that table close by when you start describing things. That I think it'll be helpful for you. All right, so let's go to some examples. And so on number one, we have selected values of the function of f. We're going to determine the degree of the polynomial. And so we're just going to start subtracting. Now, I don't actually have to find rates of change because these are equally spaced input values. So we can just do the differences. And so I would take 5 and subtract 45. And I know you guys can do this. If you just want to fill in the numbers, it's okay. So I'm just taking 1 and subtracting the previous one. All right, obviously those are not constant, so it's not degree 1. So we'll just keep on subtracting. All right. Second differences are not constant, so it's not degree 2. You might want to start writing smaller than me because I'm definitely running out of room. We're also running out of differences. And so third differences are not constant. So if it's not these, then we're in trouble because we're out of numbers, but it is. So we get 384 for both of these fourth differences, which means this function is degree 4. Right. On number 2, we have some information about the function, and we're going to see what we can figure out about the relative minimum or relative maximum value. So A asks for what values of x, if any, does f have a relative minimum? So what do you guys think? Is there a relative minimum?
-3.
Yes. Why?
It converts from decreasing to increasing.
Very good. So at -3, the function changes from decreasing to increasing. And so that's always going to be a relative minimum. And the question is, what value of x? And so we're going to give the value of x. if they had asked what is the relative minimum, what would you say? It would technically just be the y. And I know we'll talk about that a lot throughout the year, but if it asks what the minimum is, that's going to be the y value. That is the low. Okay, and then for B, what do you guys think? Maximum, relative maximum. Is there one? Is it changing from increasing to decreasing anywhere? No, so this would be none. It doesn't ask us to explain, so we don't have to. All right, so there are a bunch of questions about this function on 3. So if you guys will get your calculator and type that into y equals, we're going to do a lot of things with it. All right, so if you just look at the standard viewing window from -10 to 10, this is what it looks like. And then the first question is, how many relative minima does H have? And you can't answer that question based on this graph. Now, one thing I had some of you do on the review, and you did it also on the test, was zoom fit. Zoom fit is not good for this situation. You could try it, but it also is not helpful. So what we're going to do is we're going to look at the table of values. Now, if your calculator is on ask, you might want to change it to auto for this situation. So to change between ask and auto, you hit second window. All right. If yours is on ask, for this situation, we're going to want it to be on auto. All right, so I'm looking at my table, and I'm just going to scroll through. If my mouse would work, it'd be great. All right, so looks like we get down to -54. I'm going to keep on scrolling. And then it goes pretty high. So I'm going to change my window to try and fit the table of values. So everyone hit window. And I'm going to leave it from -10 to 10 because I think that's where the important stuff is happening in the problem. That's fine. But what I can't see is like the top and bottom of the graph. So I'm going to scroll down to y min and change that to -75. I'll make sure I'm included enough if I go that far. And then I don't particularly need to know how high. Oh, hold on, don't do that. I don't particularly know how high to go. So I'm just going to go to +75. And if it's not good, we'll know when we look at the graph. All right. Y'all got the window? Does your graph look like that? Okay. That's a pretty good graph. I can see the bottom. I can tell that it's just going to keep on going on both sides, so I don't need to worry about going any higher. All right, so that first question is, how many relative maxima does H have? What do you guys think? How many little hills? One hill. There's one little hill right there. All right, the next question. How many relative minima? What do you think? 2. All right, and then C asks you to find the absolute maximum of H or explain why it doesn't exist. Does the absolute maximum exist? Why not? Continues increasing. Very good. Keeps going up and up and up. So let's write something like that. So the absolute maximum does not exist. Because H increases forever or something like that. So as soon as you think you find the highest point, you can go a little bit higher. Now there's a typo. I did ask that same exact question again. I did not need to. So D should say, to find the absolute minimum of H or explain why it doesn't exist. So does H have an absolute minimum? Yes. So this point right here. So let's see what you guys remember about Algebra 2 and the graphing calculator. Do you all remember how to find a minimum? I'm going to do it, and then I'll write down the steps when we get it done. So you're going to hit second, and then you're going to hit trace. That takes you to the calculate menu. What do you think we want to calculate here? Minimum number 3. Okay. So you get this little flashing cursor, and it kind of tells you what to do. You want to hit enter on the left side of the minimum. So I'm going to hit the left arrow. It kind of disappears for a second, but I know for sure I'm on the left. Hit enter. And it says right bound, so I hit enter on the right. And then it says guess, that doesn't matter, just hit enter one more time. And this is what we get. So what you think you would answer is the absolute minimum of H. It's just the Y. That's the minimum value. So negative 54 point, you can say negative 54.07 or negative 54.08. But we do need to go to 3 decimal places. So either truncate or round to 3 decimal places. They're both right. Here. Sorry. Same. Here. All right, we are going to stop there. That's where I stopped last period. And we're just going to hold off on this assignment, and we'll pick back up tomorrow.